Hello friends, I'm here to talk about next part of the series that we are on. And if you recall, in the last video we have gone through different kind of algorithms of queue. So in this video we'll touch upon implementation part. So basically it means that we'll kind of look into that how we can implement queue with programming language. So let's begin. So of course, it's a demo time. So let's see how things looks in action. So what I'll do is I'll first run this and post that I will talk about what different code is doing, so that way you can understand it. So this is the code. It is similar to, I would say, the project is similar. I have added the previous stack code into different file and the queue into different file, so that it is easier for you to relate that if you understand programming design, separation of concerns, so that way we are able to take care of that as well. So this is the queue custom queue class that is kind of created to illustrate all the operations of the queue, and in this case I'm taking example from C# that is very similar with C type language, whether it's a C, C++ or even Java. So somebody knows C, C++, Java, they can very much relate to what C# is doing. Okay, so let's begin. So as always, the first operation is Enqueue. So enter a choice, so I'm adding 1. Okay, and it asks that how many members you want to enqueue. So let's say I want 5 members, and then it will pop up a screen for me 5 times. So let's say I'm entering 11, 12, 13, 14, and 15. So 5 members got inserted. So look at their order. So 11 came first, then 12, then 13, then 14 and 15. So it means if I show in the list, that is option 4, all of them should come together, unlike stack where the latest inserted member was coming first, because stack is not just one way open, right? So queue is 2-way open, and hence the order should be maintained. So I'm entering 4 to check the list how the data looks like, and yeah, I think I need to stop that debug mode. So let me disable it so that you don't get into code in that one. So I'm entering 4. And it is, look at this, so it has maintained the same order as we inserted. So 11, 12, 13, 14, 15 all came in the same order. So that is what queue basically works. So the first member that came continue to be in a you can say ahead. So it's like regular queue that we see in in real world, that the first member is always the first member. So the new members kind of keep coming from, you can say, bottom, like not bottom but backside, and the first member who came also going to be exiting first. So first in first out is what we call it. So how to kind of, so enqueue is done, and we also look into that how list is working. So it is basically maintaining the order. Now let's look at other operations. So for example, dequeue. So before I perform dequeue operation, what do you think, which member should go first? 11 or 15? So here is the guess. So 11 came first, right? If you recall, we inserted 11 first. So as per the logic, first in first out, 11 should be dequeued or removed. So if I press option 2, let's see what happens. Okay, nice. So member 11 is dequeued. So 11 was the first member, so that got dequeued. That is good. That's what we wanted. And so because first member was 11, so it got dequeued. So now we should have 12, 13, 14, 15. How to check again? We'll basically put the option 4. So yeah, 12, 13, 14, 15. So 4 member got left. So that's how this dequeue is working. So it is taking out the member that got inserted first. So in this case 11 got inserted. So let's say let's do one more time and then we'll pitch into the other operation. So let's do DQ again. So this time I think you might have understood that 12 should go because 12 is the second earliest member that came in this queue. So if I'm putting 2, okay, yeah, right, so it's doing good. So 12 got DQ'd. Now if I list the members, yeah, so now I just have 13, 14, 15. So that's what we wanted. So now you understood that basically how this DQ is working. It is working as the set principles of these operations. So that's working fine. Now let's see that what does peak is doing. So now what I'll do 3. Okay, so peak is giving me 13. Why so? Peak is basically taking the item that is there basically in you can say front. So 11, 12 got DQ'd. So now the next member is 13 that is waiting to be DQ'd, if you understand that way. So 13 out of these 3 members, 13 is a member that came earliest. So that's what we call it as a peak. So peak is kind of giving us that data. List we already kind of tried several times. Make empty I'll try in the last, and same goes with exit. So now I think we touched upon major operations. Make it empty will just kind of make this you can say reset it. Exit is nothing but just a program for all particular purpose. It will just exit out from this operation. Now let's spend some time on understanding the code, how this is working. So for that, it's pretty simple code. So if you look at program, that is a starting point. People who worked on C, C++, Java, they understand that what main means. So it is similar in that way. So I have commented out the stack code that we covered in the previous videos. I am currently showing you the queue code. So I'm going here and let's look at this. So what I have done. So unlike a stack, here we have 2 pointers, front and rear. We talked about what front and rear means in the previous video. So if you are new to this, if you have not watched the previous video, I would suggest that you go to the video number 5. That is talking about what this front rear means. So that will help you. And if you already understand, just move on. So max size is basically that how much what is you can say length, or you can say capacity of this queue that it can accommodate. So basically it can accommodate maximum 10 members, and the reason is that it is not dynamic, because as we know, array is a fixed length data type. So we have to define basically what is a starting. Initially we have to define that what is our, you can say, capacity and max size is just exactly doing that. So queue is basically implemented using array. So we have array of 10 in this case, 10 size, and that is basically the variable name is queue, and it is initialized by the -1, just to make sure that it is like, because you may have the number as 0 also, right? So -1 is kind of even -1 can be done, but -1 is basically saying that there is nothing. So if there is a -1 means you have not inserted, just to differentiate the real numbers with you can say default one. So we have just initialized all the places. So basically in array, all the 10 places will have -1 to start with. Okay. Let's now look into this main menu. So main menu is basically pretty much similar to, in case folks have watched basically the previous video, but if you have not, it's pretty simple. So one is basically trying to add the enqueue the members. So initially we are just checking that it is not full. If it is full, of course we can't proceed for inserting members. So we are just popping the message that could not insert data because queue is full. If it is already touched upon 10 capacity, but if it not, we are basically asking that how many members you want to enqueue. Since we have capacity of 10, we are also putting a guiding message that the member should be between 1 and 10, because that is how our capacity looks like. And then we are checking folks who comes from C#. Of course, even Java has some similar, if not same, similar syntax to check whether inserted member is an integer or not. So in C# we have try part. So I'm checking that somebody is inserting the real, you can say, number, not any ABC or anything. Of course, it may be by mistake, but we are trying to handle that case that it should be number. If it is not number, basically we are not letting it go inside. But if it is a number, if somebody inserted the valid number between 1 and 10, we are going inside. And basically we are checking that the count, of course, it should be between 0, like it should be between 1 and 10. If it is somebody is planning to enter, let's say 11 members, we are not allowing because we can't handle that more than 10, size is 10, so we can't handle numbers more than, basically count, we can't handle count more than 10. So we are checking that if it is below, like within limit, we are basically going ahead and how many, based on the count, we are popping, or we are allowing user to enter those many numbers, and we are calling this Enqueue operation. We'll touch upon Enqueue in a while. If it is, of course, if it is somebody entering, suppose despite reading this, or maybe somebody ignored this, that there is a ask to enter between 1 and 10. Suppose somebody entering 11, 12, or any bigger number. So we are saying that, we are again saying that please enter number between 1 and 10, and if person understood, of course, then we are letting the person in if the number is becoming between 1 and 10. But in case somebody just really playing around and not doing any serious operation, just kind of trying it, so they are saying that you have exceeded number of wrong attempts, because it is a waste of time, right? So we are we are basically moving ahead. Now let's look into Enqueue operation that is being called from here. So we'll quickly jump here. So we are checking that if it is not full, of course, what is the definition of full? Full is basically when max size is similar to rear, right? Rear is a number, the counter that is keep increasing as you saw when we were doing operation. So if it is touched upon max size, then it means it got full. So if it's not, then only we are going inside and we are adding into queue and increasing the counter, and also popping a message that is data got enqueued. If it is full, we are saying that we can't insert anymore, and so that user is aware what's going on here. For option 2, that is dequeue, we are dequeuing from front, because dequeue always happen from front. So in that case, and after dequeuing, we are adjusting the basically position, so that we don't, if you look at previous picture that we have in the previous video, we are basically you can say removing member. So inserting member from, you can say from, if I put direction left side and removing member from right side. So if some member is got removed from right side, we are adjusting that additional, we are decreasing the counter that is here, and we are adjusting that additional place. So adjustment is happening using this for loop, and again the empty place that got the member got removed, we are initializing with -1, so that we have the clean data. And hence, if you understand that dequeue operation in array is not O1, it is ON, because it will depend on how many members we have, right? So that is one quick catch about complexity part, complexity of this queue operation, basically time complexity. Peak, as we discussed, peak is giving the front member. Is full, we discussed that it is max size, then it is full. If it's not, then it is not full. And in the last, basically empty, we are checking with front and rear, because both are being initialized initially with 0. If you look at here, so if there is still 0, means it is empty, right? So it is accordingly it is being popped up. That's pretty much quickly talking about references. So if you want more details, you can go through some of these basically links. And this is pretty much at a high level about me, who am I, what I do. And if you find this useful, you can subscribe it. Thank you.